Pimela, here we are doing number one. I'm gonna start straight from number one. We are given the following terms. The first term is -1, the second term is 4, and the last term is 9. And they form a sequence, but they didn't tell us what type of sequence that is. And they've asked us to determine the general term of the above sequence. I will start with 1.1. Before you can even try to answer 1.1, you need to check what type of sequence we are given. That -1, 4, and 9. Is it arithmetic? Is it geometric? Or is it quadratic? It is arithmetic. Why is it arithmetic? It's because when you take term 2 minus term 1, you will get 5. And when you take term 3 minus term 2, you will still get 5. Meaning that it gives you a common or constant difference. Let's try that out. What is 4 minus -1? What is the answer? It gives us 5. And what is 9 minus 4? It gives us 5. So that sequence, we can conclude that it is an arithmetic sequence because it has a common difference, a constant common difference of 5. Now, determine what type of sequence we got. It will help us to use the correct general term or nth term. For arithmetic sequence, to use the general term we are going to use will be Tn is equals to A into n minus 1, and outside that will be multiplied by D, where A is -1 and D is equals to 5. And for us to find 5, I took T2 minus T1, and that gave me 5. And it will give you the same constant difference when you take 9 minus 4, which will give you 5. Break the bracket in the second term by multiplying out by 5. 5 times n will give you 5n, and 5 times -1 will give you -5. -1 and -5 are like terms. We are simply going to add them. Fortunately, they've got same signs, so we'll keep the sign and just add 1 with 5, and that'll give us 6. So we have 5n minus 6, and that is your general term. Done. 1.2 wants us to determine the 15th term of the sequence. There, they're simply telling us that n is equal to 15. Go to the general term wherever there's n, substitute 15. Simplify this. 5 times 15 minus 6 will give you 69. So the 15th term will be equal to 69. One 1.3 wants us to determine the last term. Actually, it wants us to determine how many terms are in the sequence if the last term is 2004. Again, once you found the general term, use that general term, okay? So for us to find the last term, obviously, we have to use the general term where they're telling us Tn is equals to 2004. Now, in this case, to determine how many terms we've got in the sequence, we'll have to calculate the value of n because we are given Tn. The value of n will actually, if we're calculating the position of the last term, the value of n will also represent the number of terms we have in that sequence. Use the general term where there's Tn, substitute 2004 to solve for n. Transpose -6 to the left-hand side, it will be +6. 2004 plus 6 will give you 2010, then divide both sides by 5, and will be equals to 402. Now, 1.4 wants us to determine the series in sigma notation. So that's where you have to use the capital letter S, which stands for sigma notation, and that is instructing you to find the sum of whatever you have in front of the sigma notation from the position of the first from the term of the position that you're given, which is below the sigma notation, up to the term of the position you're given above the sigma notation. So we've got n is equals to 402. We are adding from 1, and the general term is 5n. That one will be at the bottom of your sigma notation, 402, which is the last term, the position of the last term, and that will be 402. In front of the sigma notation, we'll put in the general term. If it's arithmetic, your general term will look like a straight line. If it is geometric, your general term will look like an exponential expression. And if it was quadratic, then it'll look like a quadratic equation or quadratic expression. Please note, to find the sum of a quadratic sequence, you will have to add them bits by bits from one term to the next, and there's no formula for you to find the sum of a quadratic sequence at this moment. All right. So that's why you'll have to add them manually, and they won't give you large numbers if they ask you to find the sum of a quadratic sequence. They'll just give you small numbers that will enable you to add them bits by bits or term by term, that is. Okay, 402, I did specify that it represents the position of the last term we add up to, and in front of the sigma notation you'll have the general term, and at the bottom of your sigma notation you have the position of the term that we add from. All right. 1.5 wants us to determine the first 15 terms. For us to determine the first 15 terms, because we are dealing with arithmetic sequence, we'll have to use arithmetic series. All right. The formula for arithmetic series is Sn is equals to n divided by 2 into 2a plus n minus 1, and multiply that by d, close brackets, where n represents the number of terms that we are adding. Right. In this case, we are adding 15 terms, the first 15 terms. And a is -1, you were given that is the first term we are adding from. Okay, it doesn't represent the first term as such, but it represents the first term we are adding from, and I need to specify that. So a was going to be 9 if we were adding from the third term. Understand that. Okay. And d represents your common difference. Substituting this, you'll have S15 is equals to 15 over 2 into 2, open brackets -1, close brackets, plus 15 minus 1, which is 16 times 5. All right, and that will give you the sum of the 15 terms will be 510. And that's it from me. Please don't forget to subscribe. If you need extra lessons, please feel free to use these contact details. Thank you for watching. Kgotso.